ಶುರು ಮಾಡಿ.
Okay. Good morning to all of you. I welcome all the KPA members, students, and other invitees to this special online talk. As you know, we have been conducting this series of online informal talks on variety of topics, all the way from quarks to quark model of elementary particles to cosmology. So with the hope that our members and students get to know about a variety of topics from experts so that they can pursue these topics further depending on their interest. So these are informal talks, so you are very free to ask questions and participate in the talks. So, and also one more thing, as you know, NEP also recommends that we encourage interaction in Kannada, local languages, with our students and teachers. They have realized that it is very important that communication of knowledge is more important than the language itself. So therefore, we have noticed that many students and even teachers find it very hard to communicate in the foreign language, namely English. Therefore, it may be permitted. It's not very. It's not a problem of time if you speak in Kannada and also share your knowledge in Kannada. So since the speaker knows Kannada very well, ನೀವು ಕನ್ನಡದಲ್ಲೂ ಪ್ರಶ್ನೆಗಳು ಕೇಳಬಹುದು ಅಥವಾ ಕಾಮೆಂಟ್ಸ್ ಮಾಡಬಹುದು. So that is a very informal series of talks meant for all at the general level. Okay. So now before I request Professor Ramakrishna Damle to talk about the subject of global climate change, problems and challenges, I'll give you a brief introduction, even though it doesn't require much introduction to many of the teachers in this area, students and teachers in this area. So, mute yourself. So, Professor Ramakrishna Damle has retired as Professor of Physics from Bangalore University, and he also served as chairman from 2015 to 2016 in the university. He completed BSc, MSc and from University of Mysore, and PhD from ICSE Bangalore. His research interests are mainly in the field of solid-state ionics, NMR, ESR studies in solids, zero-field NMR in ferromagnetic materials, radiation damage studies in devices, and so on. So far, he has guided 10 PhD students and 5 MPhil candidates to their degrees and completed 7 research projects. He has over 80 research publications in national and international journals and presented over 70 research papers in international and national conferences and symposia. And he has won the prestigious Commonwealth Academic Staff Fellowship for the year 2005 and visited as a visiting professor at University of Kent in the year 2000, in the academic year 2005 to 6. He has also visited Northeastern Hill University, the Department of Physics there, as a visiting professor during 2017. He has been a member of several scholarly associations and bodies, such as he served as the Vice President of Asia Pacific EPR ESR Society during the term 2016 to 18. He has served as a life member he is a life member of National Magnetic Resonance Society. He is a life member of Alumni Association of ICSE, a life member of Association of British Scholars, Karnataka chapter, and of course he has been a life member of IPA and also served as former secretary. And now we are glad that he is a life member and a very active person of KPA. So with these few introduction words, I now request Dr. Damle to talk about the subject. He may take about 1 hour, 1 hour, 10 minutes, then answer a few questions. Thank you. So please take over.
Okay. Thank you, Professor Kavli, for introducing me and for the nice words. And I'm going to talk today about global climate change. What are the problems and prospects we have, problems and challenges we have. I have given this talk at a popular levels in various schools and colleges. But today, since most of the audience are physicists, I will make this talk little more technical. So now I don't have to emphasize that global climate change and global warming is a widely discussed subject in the recent times. Everybody is talking about it. If you look at the media, there are media reports, there are protests organized all over the world, and there are articles written, there are seminars held, all kinds of things, activities are happening, creating an awareness about the global climate change and global warming. And there has been a lot of awareness, a lot of panic also, right? So
Yes.
we are, I mean, why this is happening is simply because that we are witnessing the ill effects of global climate change and global warming over the last 1 or 2 decades. What are the manifestations of global warming and global climate change? We have seen, we have witnessed heavy rainfall in some parts of the world and no rainfall at all in some other parts. Drought-like situation and flood-like situation in some times, right? And there has been, increase in the sea level also in some area, in some coastal areas, and increase in the snowfall above the normal level. In fact, in the Canada and US, in the last 2 years, there has been a substantial increase in the snowfall. And we have also witnessed increase in the number and intensities of the cyclonic storms. So all these manifestations of the global climate change we have witnessed, and we are suffering from all these ill effects, isn't it? Because of this, there has been a lot of awareness and a lot of panic, not only among the government and the policymakers, among the general public also. There is a lot of panic and a lot of, people are worried about it, why this is happening. So today I am going to address who is causing the global warming or the global climate change. What is responsible for it? Is it because of the increased human activity, or it is a part of a natural phenomenon? I'm going to talk about this natural phenomenon at a later stage with the appropriate plot also. Okay. So if it is anthropogenic and if it is man-made, how do we combat global climate change? How the climate look like in the future? Right? So these are some of the questions I will address in this talk. Oh, I am not able to go to the next slide. Okay. Only one slide is coming. Next slide I am not able to go. Okay, go. Yeah, okay. Now, okay. Okay. Are you able to see this?
Yes, sir.
Okay. Now, let us begin with the basic definition of global climate change or global warming. What is global warming? By definition, global warming is the increase in the surface temperature of the Earth above that due to the natural greenhouse effect. I am going to talk about the natural greenhouse effect also in a little more detail at a later stage. And this is a phenomenon of global warming which has been observed over the last few decades. And scientists, climate scientists who are working on the model prediction of the climate, they have made a prediction. What is the prediction? The prediction is that if the human activity continues at this rate, in about 5 or 6 decades, life on our planet would be in danger. There's going to be more and more ill effects of the global warming, and the life on our planet, it becomes uninhabitable. The life on the planet is going to be in danger. That is the prediction. And these predictions are based on careful experimental observation and model simulation, theoretical simulations of the climate system. So what are the manifestations of the global warming? As I have already told you, increase in the global average sea surface temperature, increase in the global average sea level, melting of the glacier because of the increase in temperature, especially the northern hemisphere snow cover is melting very fast, and heavy rainfall in some parts of the city and no rainfall in the other part of the city, and increase in the cyclonic storms and increase in the snowfall. These are some of the manifestations. Now, remember, about a decade or before, even the scientific community itself, scientists itself, there has been a divided opinion about the global warming. Some of the scientists, a section of the scientific community was saying that, look, this global warming or the global climate change is a natural phenomenon. It's a part of a natural process which has occurred thousands of years before. I am going to show that one graph later. And it is happening now, and it is happening in future also. Why do we have to get worried about it? It's a part of a natural phenomenon. So we don't have to be worried about it. It's nothing more, nothing very, very serious. So we don't have to worry about it. So there have been arguments for and against. In fact, if you look at, there are two popular books which have been published by one by Thomas Gale Moore, who has written a book on climate of fear, and there is another book by Michael Crichton. The title of the book is State of Fear. Both these books find that the global warming is a hoax. Hoax means, husi bedrike. Sumne ವಿಜ್ಞಾನಿಗಳು ಹುಸಿ ಬೆದರಿಕೆ ಹೋಗ್ತಾ ಇದ್ದಾರೆ. It's a part of a natural phenomenon. It's not man-made. It keeps happening. It has happened earlier. It is now happening. It will happen in future also. We don't have to be worried too much. So this had been the argument sometime back, a decade back. But now there is a consensus among all the scientific community is that global warming is real. It is anthropogenic. It is man-made, and we have to be concerned about it. So, because of this, the science of climate change has been subjected to intense scrutiny because the stakes are very high. Right? Okay. Now, these climate scientists who are advocating the ill effects of the global climate change, they have to answer several questions. There is no escape. They have to answer this question. Do we have scientific evidence for the global climate change or global warming? Who is responsible for this? Is it anthropogenic, man-made, or it is a natural phenomenon? How will the global climate change in the future? And if the predictions are to be believed, then what are the remedial measures we need to take? So these questions the scientific community has to answer. They are answerable to all these questions. They have to answer. So the global climate change, because of all this, is no longer a scientific problem. Because economies of the countries are dependent on how much energy we consume, isn't it? The economy of a country largely depends on how much energy we consume, how much industrialization we have, right? So it is a political problem, it is an economic problem also. It's not just a scientific problem because the stakes are very, very high. Okay. So now the scientists who advocate global warming, they have to do model simulations of the future climate by taking various aspects into account. Because if you want to do any model simulation if you want to forecast the climate system of the future, you need data. You need the sampling data, right? How good are these data? The sampling, there could be sampling errors in the calculation of the global mean temperature, obviously. There could be discrepancy between the satellite and surface measurement, obviously. And we need to first concern about the global warming, whether it is a human activity induced or it is a part of a natural. And what is the role of the solar radiation? Okay, variation. There is always a variation, little variation in the output received from the sun, isn't it? So there is a variation in the solar. So how good are the climate models which are used for model prediction, climate prediction, forecast prediction, right? Can we believe these models? How good are these models? Okay, so these are some of the aspects which the climate scientists have to take into account before addressing or before making a forecast of the future climate. So let us look at each of these problems in a little more detail. There could be sampling errors, of course, because the surface measurement, data is collected from the surface measure. They are recorded from the automatic weather station. And we know that 70% of the globe is covered by water, right? Only 30% is land, right? So you can put up automatic weather stations more easily on the land surface. It is very, very difficult to have an automatic weather station put up on the oceans and collect data. So a large portion of the earth does not have a sample error, isn't it? So there is a sampling error. So vast area they have no coverage at all. Very few stations. There are of course a few stations put up in the ocean, but they are very, very few in India. Okay. And for any model simulation, we need to take into account both the surface measurements, data obtained from surface measurement, as well as data obtained from satellite. But we know that satellite data is available only after 1979, not before that. Before that, there were no satellite data at all. Okay. So the satellites which are used for recording the climate conditions, and these are available only after 1979. And we know that each satellite has a certain lifespan, isn't it? A satellite cannot work forever, isn't it? They have a certain lifespan, maybe 8 years, maybe 10 years, or sometimes even 5 years or 6 years. So when the lifespan of the satellite is over, and that particular satellite has to be replaced by another satellite. When you do so, there could be some problems of orbital drifts, sensor calibration, and which could affect each of these satellites differently. So there could be little problem from the data obtained from the satellite also. And solar variability. We know that the radiation or the energy received by the Earth from the Sun is not a constant. It varies. We know we have a major component is the periodic 11-year solar cycle. This one, we call it as the sunspot cycle. And the average intensity of the solar radiation received by the Earth from the Sun is about 1350 watts per minute. And it varies over in a periodic manner because of the solar cycle. Even if you take into account the variation in the solar output, the variation is only 0.1%, not more than that. So, even if the extreme case of solar variability caused all the global climate change prior to 1970, the data or the consensus is that it cannot be responsible for more than 30% strong global temperature rise since 1970. So, the solar variability is a very, very small factor. It doesn't contribute much at all. Okay. Now, before I go into the link between carbon and energy, I just wanted to draw your attention to the fact that in climate science we use two terms, climate and weather. These two are slightly different. What is weather? Weather is the state of the atmosphere at a given time and given place, okay, which changes constantly, and we have witnessed morning it will be very chilly, by afternoon it will be very hot, and by evening it starts pouring, isn't it? So the weather keeps changing from hour to hour, right? But climate is a statistical average of the weather events, weather conditions over a long period, usually greater than 3 minutes. Many times in the newspaper, these two words are mixed up. Okay, they use climate instead of weather, or weather instead of climate. So we have to understand the subtle difference between the climate and the weather. In fact, some scientists has put it very aptly. The difference between the climate and weather, as climate is what we expect, weather is what we get. That explains everything. Now, this also I don't want to spend too much because it is elementary and we all know about it. I just want to draw your attention to the fact that the major gases in the atmosphere, like the nitrogen and oxygen, which make about 99% of the atmospheric mass, okay, have no role to play as far as the greenhouse effect and global warming is concerned. Remember, it is the existence of small trace gases like the water vapor, carbon dioxide, ozone, N2O, carbon chlorofluorocarbon. These are all the greenhouse gases, which we call it, which permits the net warming of the atmosphere due to greenhouse effect. That we should remember. It is the small percentage of gases in the atmosphere which are responsible for the greenhouse effect and global warming, and not the major gases in the atmosphere, which make about 99% of the atmospheric volume. Right? And this also, this is a very elementary graph showing the variation of temperature in the atmosphere, okay, as a function of altitude. The variation of temperature in the atmosphere is not a monotonic increase or decrease, it's a complex pattern, right? In the troposphere it decreases, in the stratosphere it increases, in the mesosphere it decreases again, and in the atmosphere it increases again. So this is a complex pattern, complex variation of temperature in the atmosphere. Okay. Now, what is the link between carbon and energy? We all know that the modern civilization is heavily dependent on energy. Without energy, our life will be we can't do anything, right? And the distinction between the rich and poor is simply that how much energy they consume. Obviously, a rich person will consume more energy, a poor person will consume very little energy. And if we look at what are the global energy sources, nearly 80% of our energy comes from the fossil fuels, the conventional fossil fuels like the coal, oil, and natural gas. We have coal power plants. When you burn the coal, we have coal power plants, and we get the energy and the electricity from the coal. Similarly, there are power plants operating using burning of oil and natural gas. So 80% of the global energy is dependent on burning of the fossil fuels. And there are, of course, non-carbon emitting sources also, nuclear and hydroelectric, which provide about 13% of our energy demand globally. Okay. And only a small fraction of the energy comes from the renewable energy sources, like geothermal, wind, solar. They make about 1 to 2%. I'm going to talk about why the renewable energy is not properly harnessed globally at a later stage. Now, we have three conventional fossil fuels: coal, oil, and natural gas. If you burn any one of these, we get energy, right? But the question is, there is a chemistry question. Which is cleaner? Which is cleaner? Natural gas happens to be cleaner than coal and oil. When I talk about clean, how much carbon that the natural gas is going to put up when it is burned, how much carbon the coal is going to put up in the carbon when we burn coal for producing energy, right? Electricity. It so happens that the natural gas is little more cleaner than the coal and oil gas, because the major component of the natural gas is the methane. We know that, right? And which is in a highly reduced form. It has the lowest oxidation state. In fact, the oxidation state of methane is zero. Okay? It generates the largest energy per unit carbon levels. Now there are various fossil fuels like coal, oil, and natural gas, and this slide explains how much reservoir we have, how much reserve we have. Coal is the largest fossil fuel reservoir, and it's almost pure carbon. And you know how the coal is produced in the below the earth crust and all that. I am not going to the details of that. In fact, if you look at the estimates of how much coal we have in our earth, below our earth crust, there is enough coal supply for several centuries. We don't have to be worried about exhausting our coal reserve at all. We have enough of it. But are we allowed to use all this coal and put up more and more carbon into the atmosphere? No. And similarly, oil. Okay. Oil comes from the ancient organic life in the ocean that we all know about it. And we have a reserve of about 1.2 trillion barrels. Of course, this data is a few years old data. The latest data may be little more different. Okay. And 85% of the petroleum is carbon. We all use petroleum for our automobiles and various other needs, isn't it? Even for producing electricity. 85% of the petroleum is carbon. Okay? and how much reserve we have. How long this petroleum or the oil lasts? The current usage. The current usage, when I say it is again a little more old data, few years old data. The present usage is about 80 million barrels per day. If we keep consuming this oil at this rate, how long this oil will last? It can last only for about 4 decades or maximum 5 decades, not more than that. Then what next? Where our energy comes from? That we have to be oriented. And of course, natural gas is another type of fossil fuel, which is mostly methane, and we know that we have about 100 gigatons of carbon reserve, proven reserve, in about 192 trillion cubic meters of methane. That's we will not. So, if you look at the energy sources today, how different countries use their energy, produce their energy, and use that. Globally, we are largely dependent on the black is coal, and then petroleum, right? And white is gas, and you can look at the dot, that is nuclear power, and the hydroelectric power is also that. See, most of our energy comes from burning fossil fuels. Of course, you know that if you look at the France sometime back was largely dependent on nuclear energy. But remember, the France is also closing down many of their nuclear power plants because of the risk involved in the nuclear producing energy through nuclear power plants. Okay, so what I mean to say is that we are largely dependent on burning of the fossil fuels for our energy needs. And how do we produce? What is the global energy that is produced, and how we consume global energy? So, 13 terawatts of energy is produced globally every year, right? And out of which, US consumes 25% of the energy globally produced. They are the major users of the energy, and hence they are the major polluters also. Okay, so if you make a comparison between the average energy a citizen consumes in India and average energy that an American consumes, there is a lot of difference. An American consumes about 600, it's arbitrary units, I'm not going, it's the regular unit which we talk about. We consume about only 600 units of energy, we Indians, whereas an average American consumes about much, 10 times more than 10 times, 20 times, 11,000 units per person per year. So, they are the major users of energy, they are the major polluters. So, the world energy consumption, this graph shows how the consumption of energy is increasing monotonically over the last several decades. So, in 1970, we had about 270 quadrillion BTU. 1 BTU is, you have the conversion here. Now, if you look at what is the energy, world energy consumption in 1970 to what is the energy consumption in 2020, there is a 3 times increase. Because the increase in the energy demand is because of the increase in the industrialization, increase in the population. There are so many factors, isn't it? So, our energy demand has continuously increased over the last several decades. Now coming to greenhouse effect. In fact, many times there has been a little misconception about the greenhouse effect. We know that greenhouse effect is responsible for the earth to be kept at a warm temperature, isn't it? What is greenhouse effect? You know that the earth receives the energy from the sun. The energy received is usually in the visible region, short wavelength region, and because you have the greenhouse gases in the atmosphere, when the earth's surface gets heated up, it emits radiation back into the atmosphere, and the emitted radiation is usually in the long-wave radiation, it is in the infrared region, and the greenhouse gases will in the atmosphere will absorb the radiation and emit back. And because of this absorption of the infrared radiation emitted from the Earth's surface and re-emission from the greenhouse gases, the Earth becomes warm. So the global average temperature of the Earth, because of the natural greenhouse effect, is about 15 degrees centigrade. If you did not have the greenhouse gases at all in the atmosphere, then there would not have been the absorption of infrared rays and re-emission. The temperature of the Earth's surface would have been much, much lower. Okay, much, much lower with the next slide. So without the atmosphere, the temperature of the Earth would have been 255 Kelvin, minus 18 degrees centigrade. Remember that many of the life forms cannot exist at such a temperature, isn't it? So greenhouse effect is actually beneficial to the man. Okay, many times people, tend to say that greenhouse effect is bad, greenhouse effect is causing global warming and all that. It's not the greenhouse effect itself is causing the warming, right? Warming of the Earth's surface. It is the runaway greenhouse effect, enhanced greenhouse effect, which is causing the problem. Okay. So that we should remember, right? So, and we know what are the greenhouse gases: water vapor, carbon dioxide, etc. Isn't it? The water vapor is the most important greenhouse gas. 80% of the greenhouse effect is due to the water vapor in the atmosphere. So, greenhouse gas is actually beneficial for the survival of the life on the Earth. Otherwise, the temperature of the Earth would have been much, much lower and would have been very difficult to survive. Okay. But because of the increasing levels of the greenhouse gases in the atmosphere in the recent times, the Earth is becoming warmer and warmer, and the temperature of the average temperature of the Earth has increased. And this we call it as global. So let us look at what is the concentration of the carbon dioxide in the atmosphere over the last maybe 1 century. Okay. So before the industrialization, see, we know that the industrialization in the West happened sometime around 1900 or slightly before that, and pre-industrial year, before 1960, the concentration of the carbon dioxide in the atmosphere was about 280 parts per million. Okay. Now, what is the concentration of the carbon dioxide in the atmosphere? It has crossed 410. In fact, it is slightly little old data. I will tell you. Next graph will tell you the concentration of the atmospheric carbon dioxide in the atmosphere. 2020 data will also. Yeah. So it has crossed, it has touched almost 420 parts per million. Okay. You see, I have plotted the concentration of the carbon dioxide as a wavy nature. No? There is an increase and decrease and increase and decrease. That is because of the seasonal fluctuation. The rise and fall is due to seasonal fluctuation. Because when the photosynthesis occurs during the spring and summer, what will happen is the carbon dioxide is removed from the atmosphere, so there is a dip in the carbon dioxide concentration. When the biological decomposition occurs, the carbon dioxide is returned to the atmosphere, so there is an increase. So the seasonal variation is depicted in this. So this is the atmospheric carbon dioxide plotted in the pink line, and the carbon dioxide emissions. Okay, it's also shown sideways. Okay. So methane is one other important greenhouse gas. It's much more efficient in trapping of the heat than carbon dioxide. Okay. But compared to the concentration of the methane in the atmosphere, it is the concentration, increase in the concentration of the carbon dioxide in the atmosphere, which is becoming dangerous. Okay. So now, this is in this plot how the carbon dioxide is produced and removed, the source and sink of the carbon dioxide. Cellular respiration and by the animals and vegetation is the chief source in which the carbon dioxide is put up into the atmosphere. Okay, and the biological decomposition of the dead organic matter also puts up carbon dioxide into the atmosphere. And most importantly, the fossil fuel combustion in the recent time. Over the last several decades, The major cause for the increase in the carbon dioxide in the atmosphere is because of the consumption of the fossil fuels, burning of the fossil fuels for our energy requirement. And how the carbon dioxide is removed from the atmosphere. It's a dynamic process, production and removal, source and sink. They are a dynamic balance. I mean, there is no dynamic balance. There is a dynamic process. Carbon dioxide is a chemically non-reactive gas. What is the lifetime of the carbon dioxide in the atmosphere? It's about, some estimates show that it's about 100 to 200 years, and some other estimates also show that it's more than 500 years in the atmosphere. So it takes very, very long time for the carbon dioxide to get destructed in the atmosphere. Okay, so, and the green flame photosynthesis is one of the chief sink of the carbon dioxide. Okay, that we all know about it. Green pigmented chlorophylls consume carbon dioxide and release oxygen into the air. And dissolution into the ocean. The carbon dioxide also gets dissolved into the ocean water. So when the carbon dioxide dissociates into the ocean water, it gets converted into bicarbonate, and then it gets converted into a shell material which forms a fossilizes to form the carbonate system. That's we know. Now, is it just the increase in the carbon dioxide due to fossil fuel burning, or there is other process? There are various reasons for the increase in the carbon dioxide content in the atmosphere. One is burning of the fossil fuels and industrialization. Cement factories. You know that construction activity over the globe. In fact, the construction activity is highest in our country compared to any other country. The construction activity is highest in our country, and for this we require cement. There are so many cement factories and various other industries which put up carbon into the atmosphere, right? So, increase in the carbon dioxide in the atmosphere, thus causing the global warming, is primarily due to fossil fuel burning, and there are also other contributing factors due to emissions from the industries. Okay. So, although about 1 decade before, there had been some confusion, some argument for and against the activities of the human activity, whether it is causing the global warming or it is a natural process. There had been some debate, but now there has been a consensus among the climate scientists is that 21st century global warming is unequivocally due to increase in the carbon dioxide level in the atmosphere. Now let us look at the carbon dioxide history and projection. How the carbon dioxide is getting into the atmosphere, and we have some data here. If you look at the data from 1970 to 2020, there has been a substantial increase in the levels, the carbon dioxide fossil fuel consumption, resulting in the putting up of carbon dioxide in the atmosphere has continuously increased over the last several decades. And because of this burning of the fossil fuels, the temperature of the globe has increased. There has been an increase in the global average temperature by about 0.7 degree over the last 1 century. If you look at from 1850 to present, what is the increase in the temperature, average temperature of the earth? When I say the average increase in the temperature, global mean temperature increase is just 0.7%. It is, remember, it is an average calculation. Sarasari Lekachara saying it is not the increase in temperature at a particular location. In fact, we have in Bangalore itself, over the last few decades, we have witnessed an increase in the temperature, peak summer temperature increase by about 4 to 5 degrees. So at a particular location, there could be an increase in the surface temperature by more than 10 degrees also, right? But if you take the average increase over the entire globe, average increase is 0.7 degree centigrade. You can ask a simple question. It is not even 1 degree rise in temperature. It is less than 1 degree rise in temperature. Can an increase in surface temperature by less than 1 degree can have catastrophic effect? Yes, it can have. Even 1 degree rise in temperature of the earth can result in 10 centimeter rise in sea level, right? The sea level can rise by 10 centimeters. In fact, there is a documentary film, somebody made by some Indian film, amateur filmmaker, on what is happening in the Orissa coast. More than 15 to 20 villages all across the Orissa coast have submerged under the sea in the last 25 years. Okay, because of the increase in the sea level. More than 15 villages, they do no longer exist. They are under water. They are under seawater. They have vanished into the sea. Right? So the global average sea level has increased as a result of this. It is a big danger for all those habitats in the coastal region. And increase in the sea surface temperature also results in the melting of the glaciers. Okay, when the melting of the glaciers occurs, that has happened, it is happening at a very, very fast rate, and people are monitoring what is the snow cover in the Arctic region, what is the snow cover in the Antarctic region, and continuously it is being monitored over the last several decades. And the data shows that the snow cover is rapidly decreasing, and when the snow melts, where does it go? Obviously, it has to go into the ocean, and the water level will sea level will increase. Okay? Now, this is an extremely important plot that shows now. Well, I told you that global warming is nothing new. It has happened thousands of years before. Right? In fact, some scientists who had argued that it's a part of a natural phenomenon, we don't have to be worried about it, they take this example. This is an important, plot which shows changes or the variation in the global average temperature over the last several thousands of years. Okay, over this 18,000 of years, 18,000 years, 16,000, 14,000, 12,000. As you can see here, there has been a warming period about the dotted line here, 15-degree mark. Okay, there had been a warming period, there had been a cooler period. Again, you have a Holocene maximum, you have a medieval warm period. The medieval warm period was between 5th century to 15th century AD, and we had a little ice age also, a cooling period from 1650 to 1778. Now, an obvious question one can ask here is that when we cannot predict the climate of the future or what will happen in the next month, how can we get the data? How can we say that there were a warming period and a cooler period in thousands of years before where there was no civilization at all? Forget about having data. There was no civilization. But this is possible to do. There is a subject called the paleoclimate. So the history of the Earth climate, it's called, study of the history of the Earth climate is called the paleoclimatology. And from such studies, it is possible to obtain what could have been the climate condition thousands of years before. Okay, so that is possible. I don't want to go into the details of that, how it is done and all that. It's not very difficult to understand. So it is simple physics and chemistry. Yeah? Now, why the climate changing is then? So there is an increase in greenhouse gases, largely due to the burning of the fossil fuels, and leads to more trapping of the outgoing infrared radiation. And as a result of this, the planet's surface gets hotter and hotter. Okay? And of course, there are other anthropogenic effects also, the pollutant particles called aerosols. Volcanic eruptions, for example, volcanic eruptions can put up lots of aerosols into the atmosphere. And these aerosols can have either cooling effect or the warming effect on the atmosphere. Okay. Now, this increase in temperature due to increase in the carbon dioxide concentration and the carbon dioxide concentration in the atmosphere works in a feedback system. For example, when the carbon dioxide concentration increases because of the enhanced greenhouse effect, temperature increases. isn't it? When the temperature increases, there is more and more evaporation from the oceans and water bodies. So when there is more and more evaporation from the water bodies, obviously the greenhouse effect will increase because the water is the most important greenhouse gas, right? So when the greenhouse effect increases, then there is a rise in temperature again. So whole thing, increase in carbon dioxide, increase in water vapor, greenhouse effect, all this works in a cycle. So there is a feedback, positive feedback which is working, which will resulting problems. Now the climate scientists who are into the prediction of the future climate, they have taken various scenarios. You know that there is one body called the Intergovernmental Panel on Climate Change. You know, this body is dedicated to studying the climate system of the Earth and then warning the government and policymakers about the precautions to be taken and things like that. So this IPCC uses various scenarios for model prediction. Stabilization, if what will happen if the carbon dioxide concentration stabilizes at the present level, if the concentration doubles in future, what will happen? And if the stabilization occurs at a much higher concentration, what would happen? So, taking large amount of data into consideration, they do a model prediction. They do a, they use a model using a computer program and then predict the climate of the future. Most models show an increase in the sea surface temperature. I will show you next graph how the best estimate shows that if you have the lowest scenario, if the carbon dioxide concentration stabilizes at the present level in about 100, okay, to be more optimistic, what will happen in next 100 years? Now we are already into 2024, maybe in another 6 or 7 decades. So in 6 or 7 decades, the average rise in temperature of the Earth would be about 1.8 degrees Celsius. Likely range is 1.1 to 2.9, average is 1.8. If the stabilization happens at a much higher level, the average increase in temperature could be 4 degrees centigrade. So the models show that we are going to have an extremely important global warming process in the future. So, what are the causes for the global climate change? Increase in carbon emissions, increase in population, of course. Increase in population means increase in the energy demand, obviously, and excessive land use for cultivation. I mean, that the forest, the green cover, is the important sink of the carbon dioxide, isn't it? So, if we cut forest and then destroy our forest, then and use it for cultivation, we are we are destroying the major sink of the carbon dioxide, isn't it? Of course, pollution is one other natural or man-made process. Natural is due to volcanic eruption. Man-made is due to fossil fuel burning and various other processes. Okay. For example, in the North India, after the farmers raise their crop, they burn the stubble, isn't it? Okay. So when they burn it, I mean, they are putting a lot of carbon into it. ಕೊಳೆ ಸುಡೋದು ಅಂತ ನಾವೇನು ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ತೀವಿ. ಸೊ ಈ ಕೊಳೆ ಸುಟ್ಟಾಗ we are putting a lot of carbon dioxide. So the septic approach is that it is not an immediate concern. Of course, it is happening. It's a real problem. But the observation shows that the climate change in the past few decades and the predictions for the next several decades is very, very alarming. Although there are arguments for and against the global climate change and global warming, which may cause catastrophic, changes in the climate pattern, in the monsoon pattern, and various other manifestations. And there has been a consensus among the scientists that the global warming is real, very much happening. We need to be concerned about it. Well, I mean, I don't have much time, but I will quickly go through it. See, I told you that IPCC uses model prediction. They use mathematical models for predicting the future climate, isn't it? What is this model? Let us look at this model. I am not going into the details of that, but I will give you some glimpse of this general circulation model. So, the models which are used for prediction of the weather or the prediction of the climate of the future is called the general circulation model, GCM. And what is a GCM? A GCM is basically a mathematical representation of the atmosphere, land, ocean system. And they are based on physical, chemical, and biological principles, and they are supposed to include all the known phenomena of the system. And what are the ingredients of the GCM? Atmosphere and various processes that occur in the atmosphere. I don't have time to go through in detail. And the land and the ocean. Right? So these are the ingredients for the general circulation. And then these general circulation models have to take into account lots of things, isn't it? How do you model the atmosphere? The winds, water vapor, all these things are taken into account. We know that wind is a velocity of the fluid, isn't it? So the mass of the fluid must be conserved. So you apply the conservation laws, momentum must be conserved, you apply the conservation of momentum laws, conservation of mass laws, and then this equation will help you to determine it. I am just giving a simple example here. So similarly, you can model various other dynamics of the atmosphere in a similar fashion. I don't have much time to go through that. Okay. Like, for example, I will just give you a very simple example. So there is a radiative equilibrium of the Earth, isn't it? So you can write down a simple equation for the incoming energy from the sun, which is balanced by the outgoing energy. So if you write this equation, you can determine the temperature of the Earth. Right? Similarly, you can model the dynamics of the atmosphere and then predict how the temperature, various other atmospheric conditions will change in the future. All these things can be done. So there are various types of models which are used by the climate scientists. There are simple models, energy balance model, radiative convective model. There are very complex models also. Hybrid models are also used. Atmospheric GCM with a mixed layer. I mean, there are complex models which are used. They are not easy to handle, right? And all these models, different types of models are used for predicting the climate for different purposes. Each of this model, a computer program, they have to use a certain grid size. Typical grid size which is used is about 100 kilometer horizontal and 1 kilometer vertical. Right? This is the typical grid size which is used. Remember, if you try to reduce the grid size, the model prediction, the computation becomes much more complex. So you can't reduce the grid size to any arbitrary small value, isn't it? So even if the grid size is taken as 100 kilometers, the model computation becomes so complex, right? It is very difficult. You require large computers to do it. And then how the model simulation is done and what is the typical general circulation model which is used. For example, you know that the National Center for Atmospheric Research is situated in Hyderabad. This center makes use of a community climate system model for weather prediction. And I will give you the glimpse of the computer program which makes use of, which is used for the model simulation. This is a coupled model which has about 230,000 lines of statements in the computer program. There are about 150,000 uncommented or non-blank lines in the computer program, and there are about 1,600 subroutines and functions which are written in 470 files. Even the medium complexity community climate system model used by NCERT in Hyderabad, you can imagine what is the complexity, right? So the climate models, the models which are used for predicting the future climate, they are extremely complicated and you require a large amount of data, compilation, analysis. Okay. It's not an easy task. It's a problem is interdisciplinary. Only a physicist cannot handle it. Only a chemist cannot handle it. Only a mathematician cannot handle it. Only a computer programmer cannot handle it. You require a synergy between various disciplines to run a climate. Okay. And you know that you can be a specialist in physics You can be a specialist in mathematics. You can be a specialist in computer programming. Can you find a person who is specialist in all the three disciplines or the four disciplines? No, it's extremely difficult. So since we have the lack of trained manpower who can tackle these climate systems, models and simulation problems, and we have limited data source also. These are all some of the problems associated with prediction of the future climate. In spite of all these, scientists have done extensive research. They have taken lots of data available from satellites and various weather stations, and they have used the best possible infrastructure and best possible manpower to run the models and do the simulations for the future prediction of the climate. Okay. So the weather and climate predictions may go wrong sometimes due to all these factors, because it is a multidisciplinary problem. Don't have trained manpower, all this experience. So, but still, the global climate change is very much happening. It's our day-to-day experience, as I have explained in the very beginning. What are the manifestations of the global warming and how we are experiencing this in the last few decades and things like that. So, it is quite important to realize that it is a real thing. It's happening. We need to be concerned. And if we don't do this, our life on the planet will be in danger. Okay. Now, what are the solutions? Solution is to do conservation, reduce fossil fuel emissions, and go for more and more, alternate energy technology. We have to make investment. We have to harness the solar energy, wind energy, right, and reduce our dependence on the fossil fuel, right? Improve energy efficiency. That's one other important, energy saved is energy produced, isn't it? Can anyone tell me how much energy that is lost in the power transmission in Karnataka? You know that the electricity is supplied by KEB, Karnataka Electricity Department, Karnataka Power Corporation, and things like that. There are sister concerns and things like that. You know that 35% of the electrical energy gets lost in the transmission itself, because we have such a poor transmission technology, isn't it? You look at the power pole near your house, how shabbily the wiring is done, isn't it? You never know which wire goes where, right? Only the lineman will know. So because of all these, improper management, improper wiring, improper, transmission technology, we lose a lot of power in the transmission. So we have to decrease, you have to improve our energy efficiency and transmission efficiency and decrease carbon intensity and make investment in the alternate energy technology, and of course population control is one other important aspect, but it is a difficult task because once you say population control, there are various other political things coming to that. So, and we have to change our lifestyles. Unless we make a change in our lifestyle, it is very difficult to reduce power consumption. Okay. So this, the best solution is the following. And what do we do if we cannot reduce emission in fossil fuels and sacrifice our lifestyle? Of course, there is a proposal which comes from the geoengineering. Okay. It's a tool to mitigate climate change. Professor Kagi, do I have another 5 minutes?
Yeah, another 5-10 minutes you can go. Sure.
I will take another 5 minutes.
Yeah, no problem.
People are talking in the recent times about geoengineering schemes as a tool to mitigate climate change. In fact, all these geoengineering schemes are only at the proposal stage. Nothing has been realized yet, but they are working it out. I will tell you what are the geoengineering schemes. So, what is geoengineering? Geoengineering is basically an intentional large-scale manipulation of the climate system to mitigate climate change. So, you modify our atmosphere, temperature, and ecology and topography of the Earth. The figure here shows that you have the Earth in the spanner. You tamper with the atmosphere, so you have geoengineering. Okay, if you tamper, you can do geoengineering. You can combat to some extent the global climate change. But what are the schemes? Okay, what are the schemes? There are sunshade schemes people are talking about. The sunshade scheme basically involves dispersing a large number of reflectors and mirror at a point where the gravitational force vanishes, so that the light coming from the sun can be reflected back, so that the energy received by the earth can be reduced. Right. So this is people are talking about this, and this is a hypothetical, scheme that. But how much it costs? It's going to be extremely expensive. It costs 6% of the world GDP. And if you want to know little more about the geoengineering schemes, you can read the article in Current Science by G. Bala. G. Bala hails from Divicha Center for Climate Change in the Indian Institute of Science, attached to Center for Atmospheric and Oceanic Science. Okay. And cloud brightening is also one other scheme people are talking about. What we do is the seawater is sprayed into the atmosphere and brighten the cloud. When you brighten the cloud, you can scatter away the sunlight. So that results in the cooling. People are talking about this. I will not go into the details of that. And then, genetic modification of the crop or the leaves. You know that darker the leaf, it absorbs less light. That's basic spectroscopy, right? So if you genetically modify the color of our crop, you can reduce the absorption to some extent. And one other straightforward method is removal of the atmosphere from the removal of the carbon dioxide from the atmosphere itself and segregate into terrestrial vegetation. In fact, it's going to be extremely difficult process. And there has been some effort. People are talking about some models, machine models to remove the carbon dioxide from the atmosphere. And then there is a Virgin Earth challenge also, which is put forward by Richard Johnson, who is a businessman, and Algo, former vice president of United States, who is now a climate champion, right? Together they have launched a Virgin Earth challenge in 2007. Those who demonstrate a viable commercial design of the removal of the significant amount of carbon dioxide from the atmosphere, they will receive a cash prize of 100 crores. No one has climbed, and our younger generation, it is open for our younger generation to try. Well, this amount, of course, this geoengineering schemes has a lot of problems. It has ethical problem, economic problem, scientific problem, technological problem. International cooperation is required, and there should be a collective leadership also. Who will take the mantle? That's a big question. Who is authorized to do that? Who has authorized to do that? These are all some of the things we need to worry about. I don't have time to go through in details all this. But the best option, if we can't do geoengineering, the best option is to stop tropical deforestation and then go for tropical afforestation, so that the carbon can be removed from the atmosphere, because you know that the green coverage is the best source for best sink of the carbon dioxide, and planet, so that the planet can cool through cloud feedback, and we will be able to reverse the historical difference. So we should remember that the biosphere supports human life, but we should never forget its boundaries. Okay. So far, we have lived in this planet which is habitable, but it is our moral responsibility to leave this planet habitable for our future generations. So, with this cartoon, I will end it. And if there are any questions, the questions are.
Yeah. Thank you very much. Now, if there are any questions, you may raise your hand and ask your questions. Anybody would like to ask questions or make any comments? Okay, I have a few simple questions.
Yeah.
One of them is this climate change and low temperature increase. This is happening everywhere.
Yeah.
So I want to know how uniform it is in space and time. By that I mean, the Americans or the Chinese or the Indians, we have been using the carbon fuels, fossil fuels, and producing carbon dioxide and so on. It's the rate of increase in temperature, the rate of production of CO2 uniform in different regions and at different times. In the past, in the industrial revolution was taking place, there was more amount of carbon dioxide was produced. So are they experiencing the Western world and industrial world? Are they experiencing a rapid change in the climate or not? Is it all the weather is such that the weather pattern and wind pattern, everything gets uniform. Can you say something about that uniformity in space and time?
Yeah. See, when we say that there is a increase in the average temperature, it is an average over the globe. It's not at a particular particular place. At a particular place, the increase in the temperature might be much higher than 0.7 degrees. And see, the entire globe and the entire habitation around the globe is putting carbon into the atmosphere. So you cannot, segregate the amount of carbon used by a particular country and how much it is contributing to the global warming. That is difficult to do that. You can only do an average calculation because once the carbon dioxide is released into the atmosphere, it goes everywhere. It gets convected throughout the atmosphere uniform. Right. It does never get concentrated in a particular country. I mean, over the atmosphere in a particular country, isn't it? So it gets dispersed into the entire atmosphere. So the contribution from each of the country against their energy usage is difficult to estimate. So what IPCC is doing that if the concentration of the atmosphere, I mean concentration of the carbon dioxide increases at a certain stage, at a certain level, how the temperature in the future can change. That calculation only we can do.
Okay. Professor Srikanta wants to ask a question.
Sir, good afternoon, sir. Professor Damle.
Yeah.
No, sir. It's a comment that I want to make, and then I need your opinion also on that. You know that in the Pacific Ocean, we have thrown so much of plastic to the ocean. Now we have plastic, garbage patch in the Pacific Ocean itself, which runs to around 1.6 million square kilometers. I mean, the area covered by that. And I'm told that even that is also contributing to the climate changes. In the sense, the plastic, due to solar radiation, it emits greenhouse gases.
Yes.
And all the green gases also they are getting added because of the plastic patch, and that's contributing to the global warming also.
Well, see, when we talk about pollution, pollutions can be of different types. Air pollution, for example. Air pollution is going to increase the greenhouse effect and then cause increase in the carbon dioxide. Okay. So if the pollution in the atmosphere increases, there is a increased absorption of the infrared radiation causing the enhanced global warming. Okay, enhanced greenhouse. And the pollution, plastic pollution in the water bodies is a different problem. Right? So when plastic pollution in the water bodies, including the ocean, is going to cause a danger for the aquatic life. That's a different problem.
That's right.
Right. And if you burn plastic, not only carbon dioxide gets released into the atmosphere, some of the harmful chemicals, much dangerous than carbon dioxide, also gets into the atmosphere. For example, CFC, right? Chlorofluorocarbon.
Yeah.
So when the plastic is burned, we are putting more and more poisonous gases into the atmosphere. So the plastic has to be recycled. It should never be burned. So burning of the plastic waste is a big problem throughout the world. That's a very different problem, which is polluting our atmosphere and causing enhanced greenhouse.
The same thing, what is happening here is not the burning in the conventional sense what we are talking about. It is because of the solar radiation there will be heat, and sometimes the plastic gets converted into microplastics, and that leads to the emission of these greenhouse gases. That's what the studies.
See, plastic. What is a plastic? Basically, it's a polymer, right?
Yeah, it's a
basically
polymer.
a macromolecule. It's a polymer. So when the polymer gets exposed to sunlight, there is a degradation of the polymer, isn't it?
Yeah.
There is a polymer, we call it as polymer degradation, which is well known in polymer science. So when the polymer degrades, when the polymer is heated, it is going to release some of the harmful chemicals also into the atmosphere. Okay, but I don't think there has been an estimate of what kind of pollutants that are released into the atmosphere because of the heating of the plastic and things like that. I don't think there has been any estimate like that. But it is certainly going to cause problems when the polymer is heated because of the polymer degradation.
Thank you.
Sir, when the polymers are heated, I read somewhere that there is one very poisonous gas by name dioxin.
Carbon monoxide also gets released because of the burning of plastic.
Yeah.
Carbon monoxide is
Dioxin,
very poisonous.
dioxin gas is also released, which is very
Yes,
poisonous
and
as a
it is
result of
going to,
polymer
it
heating.
is going to destroy the ozone in the stratosphere also. These pollutant gases released from the industries and burning of the waste, plastic waste, is going to destroy or reduce or deplete the ozone in the atmosphere. When the ozone gets depleted, then the ozone concentration reduction in the atmosphere cannot stop the ultraviolet rays from the sun, isn't it? So ozone, presence of ozone in the stratosphere is a protective cover which stops the ultraviolet radiation. But with the ozone depletion occurs, then that is a different problem. That's also environmental problem. Okay. Ozone is also a greenhouse gas. Remember.
And clearing the plastic garbage itself is a different problem.
Yes,
Yeah.
yes, sir. See, unless there is awareness among the public, see, awareness among the public is very difficult to come in our country because most of the populace are uneducated and they are irresponsible. So I must say that there should be a forceful implementation of the certain discipline among the citizens. When that comes from the government with the help of the citizens, I think we can tackle this problem. Otherwise, just say that, we should be aware of that, we should reduce, that doesn't help. There should be some mechanism to do that. Strict laws should be implemented.
Yes.
Okay, any other questions?
Professor Ramakrishna Damle, this
Yes,
is
sir.
Rudra Swami.
Tell me, sir.
What is the role of chlorofluorocarbon released by the air conditioner and refrigerator on
Yes,
global
yes.
climate change?
Yes, I told you, among the various greenhouse gases in the atmosphere, CFC, chlorofluorocarbon, it's also an important greenhouse gas. Right? If you look at the absorption bands, IR absorption bands of CFC molecule, it has a very strong absorption band. Right? It has a strong absorption band in the infrared region. It also is a very important greenhouse gas. And most of the refrigerators and the fridges which we use in our in the domestic preppers, they use a fuel. They use what is called what we call that liquid, which is used for cooling, coolant, which is called the coolant. That is a CFC only. That releases that coolant when it gets circulated and when it gets used up in the refrigerator. That releases CFC into the atmosphere. This is also a very important greenhouse gas, and but there are various reasons. Burning of plastic, and then even the chemical reactions which are happening in the atmosphere, they also have an impact on the
And one question from Professor Somshekhar.
Yeah,
Professor. Okay, Somshekhar.
Yeah, Professor Damle, good morning and thank you for your very informative presentation and useful. So my question is related to little fundamental issue.
yeah.
As long as whatever may be our science, modification, changes, adaptation, using the science and technology, unless my feeling is that unless we change the mode of political economy, so which is operating today, for example, capitalist mode of system, will it be possible to control anything what we are discussing unless we change? So which is basically a principle based on principle of accumulate, producing more, accumulating more. So will it be possible by science and technology to divert this phenomena?
Okay. See, this is a complex process, complex problem. You know that if you look at some of the countries in the West and country in America, they are already developed country, isn't it? They are developed country. They don't require too much of industrialization, isn't it? They have everything already there. They are the major consumers of energy, and they are the major polluters also. But look at the country like India. India is a developing country. So our economy is dependent on industrial production largely. Not only agricultural production, our economy is largely dependent on the industrial production. So we require more and more energy for our industrialization to create jobs, isn't it? So we cannot sacrifice our economy and reduce carbon footprint. There are many countries in the world which are not so keen on reducing the carbon footprint because they want more and more industries to come up. They want to create more and more jobs for their citizens. They want their economy to be stronger and things like that, isn't it? So we cannot sacrifice the economy and reduce carbon footprint. That's one problem. But you are saying that can we go for industrialization, reducing energy from the fossil fuel? Yes, it is possible. See, we are now largely dependent on burning fossil fuel for our energy, isn't it? But there are also other alternate energy sources. For example, solar energy. We are not harnessing solar energy to the extent that which can be done, isn't it? Which can be done. We are not doing it, but there are again some problems associated with that. I will tell you. In fact, in that article, I have brought out this analogy between the West and the developed country. See, what is happening in the West country is that they don't want to go for more and more solar power harnessing. The simply reason is that most of the oil wells and shale wells, right, in America, they are owned by politicians and big business mafia.
Companies, big companies.
Yeah, they don't want to go for more and more energy harnessing from the solar system,
Alternative
from the
sources.
sun, right? So because they will be at loss if we do that. But in India, we can do that. So we can go for more and more solar power plants and then utilize our solar energy. But there is again a little problem because harnessing solar energy requires huge investment. And the electricity produced by solar energy is going to be more expensive than the conventional. Remember that. Okay. Now we are paying 7 rupees per unit, right?
Yeah.
But if we depend only on solar energy, our unit price of electricity will be much, much higher. It's going to be much, much costlier. Okay. So, because you know that what is the conversion efficiency of a solar cell? It's only, maximum 20 to 25%, not more than that. So the solar energy, solar cells technology also has to improve. Then we can, the cost will come down, right? But, we have to have a balance.
Yeah, that's what exactly I mean. Now, no more this phenomena, this global warming problem is no more a regional problem. This is a global phenomenon.
Yeah, it's a global
phenomenon.
Lot of
Yeah, lot of political.
Political will is required. Political unity, political will, and vision for the whole earth.
At the global level, economical system at global level.
Global level is required. Economic system, political system.
And put up a pace to change at global level. I don't think we can just postpone by adopting some of these things. We can postpone the harm, but we cannot eradicate. That's my.
Some conventions are being held, like Paris Agreement, but solve implementation. Only promises are being made.
Yeah, what is the fun in adopting small changes, which is not going to solve our problem at all? So this is
global response is required.
that was exactly.
Global response.
Yeah, see, having solar power plants in a large scale and maintaining the power plants is extremely difficult. Instead of that, we can have smaller power plants situated in villages so that we can supply energy to the villages and nearby towns. It's possible to do that, but again, it requires a lot of investment.
Can you imagine the amount of energy in different forms being wasted through the wars going on?
So,
so many phenomena, very complicated issue, as you said. So we can only postpone, but we cannot. So I don't think we can from local. Yeah, avoid.
Okay. Any other
Yeah,
question?
a very good presentation. Very thought-provoking presentation. Thank you very much.
ಅಲ್ಲ ನಮ್ಮ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ದು ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ವೀಕ್ನೆಸ್ ಇದೆ, ಏನು ಗೊತ್ತಾ? ಅದು ನಮ್ಮ ಕುತ್ತಿಗೆಗೆ ಬರೋ ಯಾವುದೇ ಸಮಸ್ಯೆ ಇರಲಿ, ಅದು ನಮ್ಮ ಕುತ್ತಿಗೆಗೆ ಬರೋ ತನಕ ನಾವು ಅದನ್ನ ಸೀರಿಯಸ್ ಆಗಿ ತಗೊಳ್ಳಲ್ಲ. ಅದೇ ಕಾರ್ಟೂನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ಸ್ ಯು ನೋ, ದಿ ಕಾರ್ಟೂನ್ ವಿಚ್ ಐ ಪುಟ್ explains everything. Unless it comes to our neck, we don't act. But by the time we start acting, it may be too late. That's what
It's already too late, it looks like, sir.
Correct.
Professor Nagaraj, will you propose a vote of thanks now? Nagaraj, is there?
Sir, before I go
okay.
to the vote of thanks, I have one clarification.
Please.
Sir, in America, they are able to predict weather conditions, but not in India. What may be?
I did not touch upon that because I did not go through the GCMs in a greater detail. You see, you have to look at what kind of models they employ for climate prediction. In America and Western countries, they can predict the weather very accurately 1 week in advance. Okay, but in India, the kind of the models which they employ for weather prediction, they are not so advanced models, and we don't have large supercomputers to handle these calculations also. So because of this, we cannot predict weather 3 days in advance, more than 3 days in advance. That is our limitation. Okay.
But one reason what they are quoting is the Bay of Bengal is not predictable and it is not understandable. Even other countries, scientists have also worked on it. That's what I read somewhere.
See, Dr. Nagaraj, not only Bay of Bengal, in fact, the atmospheric dynamics, atmospheric dynamics is so complicated. There are so many parameters operating. Extremely do a model simulation, wherever it is. Okay, it is not just Bay of Bengal. I mean, Bay of Bengal, there is a rapid change in the sea surface temperature because the topography is like that. Bay of Bengal, you have a large sea ocean actually converging into a cliff there, right, in the Bangladesh. So these geographical conditions and all these problems are there throughout the world. Not only just
data points, we don't have enough data also.
I mean, we don't have enough data, but one thing we should appreciate our Indian scientists is that in the recent time, they are able to predict the cyclonic storms very accurately.
That is
so climate, monsoon, they are not able to predict very accurately, but cyclonic event, they are able to predict very accurately.
That is through satellites also. Satellites also they can monitor. Okay.
Yeah.
Anyway, thank you very much, sir. You have covered a lot.
Professor Damle, sir.
One Nisha, Professor. Okay.
Query with Professor Damle, sir.
Yeah.
Sir, sorry, I am a bit late. I joined also late. I have, sir, you were mentioning the global rise. You mentioned the value to be 0.7 degree Ks.
Yeah.
So that is, I think, over per decade, or how do you average it, or over 100 years? What time scale?
What I have shown the data since 1850, since 1850 till 20, okay. 2010 or so. They have taken the data and they have analyzed the data and they have come up with that. Compared to what is the global average temperature which was prevailing in 1850, what is the global average temperature rise that has occurred now? That is 0.7 degrees centigrade. Okay, global average, it's not at a particular location. Okay, at a particular location, the rise may be 5 degrees, 6 degrees, or even 10 degrees. Average rise in temperature is 0.7 degrees since 1.5 centuries.
Okay. And sir, the other contributions for the CO2 are like agricultural productions also. Stubble burning you mentioned. And there the crop patterns also matters. Like the paddy is will be emitting more CH4 methane. Is also
Methane.
important.
No. That is a misconception, and that is a propaganda made by the West. No, the whatever the crop you rise, okay, if you have to make use of the land for cultivation, isn't it?
Yeah.
Right? What percentage of our land is cultivable? Tell me. It's very less. So if you want to use more and more land for cultivation, you have to obviously cut your forest or destroy your forest, isn't it?
Okay, sir.
Right.
All
Okay,
right.
sir. Thank you very much, sir, because you have covered a lot on weather prediction, then climate. In fact, even from the basic definitions to the global, what is that, calculation, and all those things you have mentioned. In fact, it was a nice presentation, and you have cleared almost all the doubts which were asked by our audience. So thank you very much, sir.
Okay,
Thank you.
Thank you.
And we will, further, I would like to thank Jnanadhara. It is support, the platform is supported by Dr. M.K. Raghavendra. And I also thank Professor P.A. Cogley. And then, of course, in addition to our KPA members here, I saw that there are other members also. In fact, I thank all the members who have attended this meeting, even from India and abroad. So thank you very much, sir. Thank you. And Professor Cogley must have some announcement. Over to Cogley, sir.
We'll meet again in the coming weeks. Please join us when we have the next meeting. Thank you very much for